Okay, so we're asked to sort of make a drawing of how Newton's method estimates the root r of this function f that's graphed. So we're asked to draw the linearization at x1 equals 1 and see how it gives our second approximation to the root r. And it looks like when doing that, our second approximation ends up being a little bit bigger than 3, which isn't too far from the actual crossing of f and the x-axis. Would it have been better to start with x1 equals 4 as a first approximation, is what it asks next? Well, let's draw and see. If I linearize the function at x equals 4, as Newton's method does, then I can see where it hits the x-axis and hence what second approximation it gives to the root. So I've drawn the tangent line here at x equals 4, and it appears to give a second approximation to the root of something around 2, which would not be a better first guess because 2 appears to be further from the actual root than 3.2 is. So in this case, x1 equals 1 is a better first approximation of the root r. Now, in the second version of the quiz, we just changed the numbers up a little bit. So let's start with a first approximation of 4, which is literally what I just drew on the previous quiz. So I'm going to linearize at x equals 4, x equals 4 being the first approximation, and we know that that tangent line hits the x-axis right around 2, so that gives us, in this case, a second approximation of 2-ish. And then we ask, would it have been better to start with x1 equals 2 as the first approximation? And yes, definitely. I mean, if we had started with 2 in the beginning, we're going to get an even better approximation of the root for our second approximation. So let's go ahead and draw what that looks like. If I had started with a first approximation of 2, then drawing the tangent line and seeing where it hits the x-axis, we see it's really hard to see a distinction between where the tangent line hits the x-axis and the actual root r. So this makes x1 equals 2 a better first approximation.